Welcome to our Colorado facility, located just outside of Denver in Aurora, Colorado. One of 5 locations across the U.S., it has helped us shave days off our time in transit for our customers. Custom Tool Supply has recently joined the GME Supply and Columbia Safety and Supply family. Custom Tool has spent decades helping contractors in CATV, satellite, and other specialty industries, and joining the GME Supply family have expanded their national footprint. As with our other locations, our Colorado location features a stocked showroom, warehousing facility with option for curbside or dockside pickup, and will soon have a full training center. The GME Supply family of companies are America's premier outfitters of fall protection, safety equipment, and gear for at-height workers. We keep workers safe and productive on the job by offering customers timely service and expertise. Our gear experts are here to be an extension of your safety program, offering solutions and consulting in any way possible to make sure your gear is where you need it when you need it. One of the best ways we can do that is through our national network of distribution locations and training facilities. Everyone expects to be able to order something online or through a gear expert and get it in just a day or two, and that's what our national footprint allows us to do. Let's take a look at the time in transit for standard ground shipping from our various locations, beginning with our headquarters centrally located in Columbia, Missouri. We're local to the heart of America. Our second location opened in Atlanta, Georgia in 2015 to service the East Coast and southeastern U.S. In 2018, our location in the heart of Texas opened in Dallas, further establishing our southern presence. And this year, we've opened a location in Corona, California, where we hosted our last live stream. And just a couple months ago, we welcomed Custom Tool Supply to our family here in Denver, Colorado. As you can see, the majority of the U.S. population is within 2-day ground shipping point from one of our locations, meaning you don't have to pay extra to expedite shipments. And look for our quick ship items, which ship the same day as long as the order is placed by 6 p.m. Eastern Time, Monday through Friday. Thanks for tuning in today, and enjoy the exclusive training session ahead.
Hello and welcome to the third and final live stream here from Aurora, Colorado. This is the RF safety and rooftop worker RF safety awareness presentation. I'm here with Caleb from GME. Caleb, you want to introduce yourself?
Hi, I'm Caleb with GME. Happy to chat with folks about RF safety, how it's impacting industries that maybe weren't looking forward to that earlier on, and see what we can do to help keep people safe and productive out there.
All right, awesome. Well, with that, let's go ahead and just jump into this. So the first topic is, why is RF awareness relevant to more than just the traditional tower climbers, telecom workers? So for a long time, potential RF exposure has been limited to just those that are actually working on the structures or in the antennas, that sort of thing. But with recent technology advancements and new designs and infrastructure, that's no longer the case, right? So cell phone and connectivity solutions are moving into new places like light poles, utility poles, rooftops, and even more discrete places like inside buildings and stadiums. So can you start by going into some detail about why anyone working in construction or maintenance in a wide variety of settings should be aware of RF hazards?
Yeah, totally. I think you hit the nail on the head with the introduction with all the locations where you can find antennas now. I know that we've got some photos that we'll show as well. But traditionally, to your point, anyone that felt like they needed to know about RF already knew about it because they were climbing hundreds or thousands of feet to get up and address the work that they were doing. Now we're finding more and more infrastructure on poles, rooftops, etc. Maybe it makes sense to jump into some of the photos and
Sure.
We can show some examples. So this is an interesting example because at first glance, you might not see where there could be some exposure. But there are more and more firms that are coming up with stealth and sort of concealment solutions so that people that want to have better wireless signal, but they don't necessarily want to look at a tower in their backyard.
Yeah, that's a contentious point for a lot of people. They don't want the towers, but they want to have fast cell phone service.
Yeah, the whole NIMBY, not in my backyard thing.
Yeah.
So this facility actually was shown as an example because they put the broadcast center at the top of the facility, and then they sort of enclosed it in something that looks like it's part of the building. Maybe the next one as well. So you can see the broadcast points here, and they put the perimeter up so that folks that maybe weren't used to the hazard wouldn't get in there. But you can see folks that are working on rooftops might encounter antennas whenever they didn't run into them before.
Yeah, if you're doing HVAC work on the roof or resealing the roof, something like that, working on the brickwork, or who knows what it could be. It could be a number of applications, but now you could be exposed to that radiation.
Definitely. Here you can see this was the early stealth technology, which was paint the antennas the same color as the wall,
or at least close. Yeah.
So you can see, this employee would be working from a ladder. They might be working on something that is other than the antennas themselves. But if they're working to address something that's in that area, they're certainly working around an active broadcasting antenna. The next one. So this is actually on it looks like it's a light pole, and you'll start to see more and more stuff like this on utility poles, light poles, stoplights, etc. Anywhere that there's already some at height space that's available, it's easier for people to put equipment on that rather than build something new. Here you can see an installation which is happening on one of those small cells. You can kind of see, if you look around the technician, they're working from a basket, but you can also see they're not that far off the ground, right? So I'm not exactly sure what this is being attached to, but you can see this is sort of a dense urban environment, and the technician is installing, it's something that isn't any longer hundreds of feet off the ground. Here, another example of some municipal infrastructure which is being used. So you might see these little things that look sort of like oversized coffee cans. Some of them also look kind of like pizza boxes.
Yeah.
But you can see that they're, you can find that type of technology on more and more utility infrastructure. I think we might have, and I think this is the last photo that we have. But again, you can see a couple of folks working from just a regular lift, not hundreds and hundreds of feet in the air, working on something that's roughly the height of a standard utility pole, and it brings the hazard a little bit closer to Earth.
Yeah, and a lot of those examples were good examples of concealment too. You might not realize that those are actually antennas that are transmitting and have live power going to them. So it's not like it's your job to recognize those, but you do need to be aware that those hazards could exist anywhere.
And that's only half of the answer to your original question. I mean, the relevance based on location, that illustrates, right? If you're working around those devices, it might not be something you're used to, but there is some sort of exposure. But the second half of the question, why does it matter to more people? It's Code of Federal Regulations. OSHA 1910.97, it requires that there is an RF exposure mediation program for anyone that has non-iodizing radiation exposure. So, or non-ionizing.
Ionizing,
ionizing, iodizing, salt, RF, who knows. Either way, it's not just keeping your people safe and productive, which is always what you want to do, but legally speaking, you do need to make sure that your folks are aware of the hazards, trained to abate them as well.
Awesome. Okay, so next topic. RF exposure can seem pretty daunting while also being somewhat ambiguous, right? And there are a lot of different narratives out there about what RF can do to a worker or even a civilian. So from a technical standpoint, what is RF exposure and what does overexposure look like? What does it do to a worker?
So now I have a chance to test my non-ionizing pronunciation again. But it's just that. It is technically some sort of radiation exposure. And the thing is, I think that sounds a lot scarier than it really is. There are certainly hazards that are associated with being exposed to active RF. But going back to that OSHA 1910.97 standard, which I pointed out before, it's sort of reminiscent of how hazardous gas detection works. It's not that if you're ever around, 1 part per million of every single element that's out there, you could be at risk. It's sort of the same concept with RF radiation. It's not that you're at risk anytime that there is any sort of radiation around you, but OSHA 1910.97 sets permissible exposure limits, which means for the amount of time that you spend in front of something which exceeds the exposure limits, You have to work your way out of it. We can get into the details of that later when we talk about training potentially.
Sure.
But essentially, you need to work your way in and out to keep yourself safe, but it's not going to be like you're getting an X-ray and you're instantly in a ton of danger. As far as what the hazards are, think about it sort of like warming, but the warming happens from within, right? So the risk that's associated with that is because you're not feeling hot on your skin as if it's, solar contact or just sort of heat.
Sitting next to a space heater.
Yeah, exactly. Or just it's a hot day, right? Sometimes it's harder to tell the difference between exhaustion because you're working and, RF exposure, essentially. So the risks that are associated with it are also largely the risks that would be associated with just overheating. So you've got dehydration, exhaustion, disorientation. At the worst case, typically with anything that would be in sort of cellular broadcast, you'd be looking at maybe seizures as well as unconsciousness, just if the overheating gets that extreme. The way that I like to think about RF concerns, though, is that it's not just the hazard that it itself poses, but it's the risks that are posed to the worker that finds himself in an otherwise dangerous situation already.
Right.
So if you're working, near the edge of a rooftop, or you're working in a bucket around something,
or with dangerous equipment.
Yeah, exactly.
Yeah.
If you end up having some sort of episode, if the exposure gets bad enough that you get disoriented, or worst case scenario you become unconscious, does that also increase your fall risk? Does that also increase the risk that you drop objects? What happens to the people around you, etc.? So I think that gives you some idea of the risks. Again, it's not Chernobyl, right? But there are risks that are associated with continuous exposure to RF.
Yeah, and another piece is there are certain parts of the body that are more susceptible to RF, right?
That's true. I'm glad you mentioned that. If you think about just general soft tissues that are generally more sensitive to other risks, it's the same sort of thing. So think like eyes, ears, testes, breasts, etc., things like that.
Yeah. Perfect. Okay, so let's move more into the 5G side of things. So with these current times and the 5G movement and small cell deployment across the country, more contractors need to be aware of the potential of RF hazards, right? So what types of workers should be aware of these antennas, RF, and the potential for exposure, even if they're not actively working on those antennas or, cell antennas, radio antennas, broadcast, anything like that?
I think the second half of what you said is probably the most important. The people that are trained and know that they're going to work on cellular infrastructure are aware of those hazards. But to your point, it's the people that are working around all the new small cell equipment that need to be aware. I think when we were looking at the photos earlier, you might have mentioned HVAC technicians, etc. But if you think about it, anywhere that there is some sort of at-height infrastructure which exists so that a carrier could negotiate with either a city, a utility, or a property owner for a hotel or a high-rise, anywhere that someone could place the equipment without having to build a new tower, those are locations that are prime spots for small cells. So if you're working on a rooftop, to your point, if you're sealing the roof, if you're performing work on the HVAC system, if you're a commercial or residential, or not residential, if you're a commercial roofer, if you're a window washer.
Yeah, I was going to say window washing.
Yeah. And then, so that's kind of the rooftop exposure. But the other half of it is we're seeing a huge amount of reaction to this from municipal and utility folks. So one example, we're working with, maybe I shouldn't name it, we're working with one of the largest cities in the U.S., and we've created an abatement program with them because they had people that were consistently working around active broadcast infrastructure whenever they were working on their light poles and their traffic signals. And so we worked with them for how to keep their folks safe and the type of equipment they needed to ensure that they were.
Awesome. Okay, and staying on the 5G topic, there's a lot of misinformation out there about 5G.
True.
So if you're perusing the internet, social media, you might see some of these posts or articles, headlines that create some concerns surrounding the rollout of this 5G technology.
Right.
The FCC has recently expanded spectrum for this new band of communication, and it's caused some confusion among workers and the general population. What does the new millimeter wave band mean, and what should people be aware of when it comes to this technology? Should there be concern from the general public about 5G?
I'm super glad that you asked that question, and we can go back to OSHA in a second, but I want to make sure that I just lead from the beginning. Ensuring that people are aware of the hazards whenever they are working around this equipment is important, but it does not mean that there is significant or any risk to the general public with the deployment of infrastructure, whether it's 5G or 4G LTE, etc. The general public is not at risk, and that is dictated by the FCC. So we can jump into that here in just a second. But beyond that, the second half of your question was about millimeter wave. Without getting too technical, think about the higher the frequency of the signal that's getting pushed from one device to another, the shorter the wavelength, right? It's an inverse correlation. So when people talk about millimeter wave frequencies, they're just saying that wavelengths which previously were unallocated or were being used by something else have now been freed up so that wireless carriers can use those. So the advantage of those millimeter wave frequencies is that they can push a lot of data with very low latency. But the disadvantage is that they can't travel, the signals can't travel as far, and they also have trouble getting through, walls or windows or things like that. So essentially, that is the reason that you're starting to see more and more small cells get deployed. So 5G and the use of those millimeter wave frequencies is certainly leading to more infrastructure on rooftops and on utility poles and street lamps, et cetera, as a result of the fact that the devices need to be closer to your phone if they're going to get you the results that you're looking for. Right?
So the old technology, you could have a tower every few miles. The speed wasn't there, but it could travel farther.
Right.
The new technology, you need more antennas closer, and it's a lot faster.
So the G, for just so everyone knows, is it's generational, essentially, right? And so if you think about latency and you think about the amount of data that can be pushed, I like to use the water hose as an analogy, right? So if you're trying to get a lot of water out of a hose, you don't put your thumb over the hose, and a lot of water comes out, but it doesn't go as far. But then if you want to make the water that's flowing out go further, you cover part of the hose with your thumb, which means that less water or less data is able to get out, but it's able to go further, right? So the more data capacity that you need, the shorter the distance, generally speaking, that can travel from point to point.
Perfect.
And then I think going back to the occupational and public thing, so the FCC does have requirements for maximum exposure that people that are working around RF can have. But more importantly, they have requirements for maximum exposure that a civilian that has no idea what's going on could find themselves in. So essentially, there is no way that a civilian could find themselves around some sort of active broadcast point without there being a number of warning signs for them. And all of the different broadcast points have to be powered down low enough that the general public, if they're doing anything that a member of the public would predictably do, will never be exposed.
Yeah. So if you're a member of the general public and you're trespassing on a rooftop and hanging out right in front of an antenna and ignoring all the warning signs, then you might be in some danger, but you shouldn't be there. So
that's fair.
Don't do it.
Very fair.
And now let's talk about, you spoke on it a little bit, but establishing an RF program for your organization. So a lot of registered attendees in this session right now came from companies that may not have traditionally been concerned about RF in their day-to-day work.
That's good. I'm glad to hear that.
This concept is definitely new, but there may be some uncertainty about the appropriate next steps while they're learning all this information. So what are the keys to getting started with a new RF safety program, and where would you start? What should folks look for?
Sometimes I think that the fact that we're talking about RF and the term radiation gets thrown around, I think that it makes people maybe a little bit unnecessarily nervous, and they treat it like it's some sort of different thing. But really, you treat this hazard just like you treat any other job site hazard. It comes down to two things: training, and then ensuring that you provide the proper equipment, right? So training, the folks that are going to be working around this equipment need to be aware of how to spot the potential dangers, what to do if they are, exposed, whether that means that they need to limit the amount of time that they're there, if they need to contact someone to shut down a site, etc. They need to be trained on spotting the hazard, knowing how to react, and then the sort of signals in case something's wrong. How can you tell if maybe you're feeling some warming? What are some signs that there might be a hazard that you didn't previously spot, right? So training is the first half. But training doesn't mean anything if you don't also provide them with the equipment that's necessary. So the most important piece of equipment for an RF program is a monitor. I know previously I used the analogy that RF is kind of like hazardous gases, right? So what do people use if they're working in confined spaces?
Gas monitor.
Yeah, gas detector, right? So it is constantly monitoring whichever gases it's been calibrated to keep an eye on to see, hey, is there enough of this gas that it's posing a risk, right? So it's the same sort of concept for RF. There are devices which are calibrated to monitor that non-ionizing radiation spectrum. So OSHA 19.97 says anything between 100 meg and 100 gig. I think we should check that. But anything between this range, any non-ionizing radiation, you have to limit the amount of exposure that's there. So these devices are calibrated to read the radiation that the folks are exposed to and then provide them feedback to determine if they are in excess of the permissible exposure level. So a couple of things on this, because I think it's really important that folks know that choosing one or the other is not going to be effective. You have to have both training and a detector, right? So if you only go with training, you have two potential options that the technicians could have. So, hey, I give my people some RF training and then I put them to work. You have two options. One is going to be less productive. That's the best case scenario. And the other one's going to be less safe. So if you put people in the field without a monitor and they see a hazard, if they don't have a way of knowing if it's actually going to put them, past the permissible exposure level, every single time that they encounter an antenna, they're going to have to stop. They're going to have to find out whose it is. They're going to have to get permission to power it down if they even have the ability to, or ask whoever runs it to tune it down. That's going to lead to some friction whenever you're constantly shutting people's stuff down, right?
And it's not a fast process either.
Exactly. And the point is, there's very little chance that every time you're working around something, you need to tune it down. In many instances, you're not going to have too much exposure, so you can just leave it running. It's not a big deal because you're not directly in the path or it's not powered up enough anyway. So just knowing that the hazard isn't significant enough, you can be much more productive and you don't create friction with everybody else.
Right.
So that's phase one. But the other option is that it's just less safe. And it's that people think, it's not really that big of a deal. They don't do anything to address the concern. And then you run into all of the hazards that we talked about previously with warming and then sort of that amplification of the other hazards. You're making somebody potentially get overheated, dehydrated, maybe put themselves unconscious over time, and maybe they're at the edge of a rooftop.
Right.
So I think those are probably the biggest keys.
Sure.
I think, do we have some photos of the ones that we generally recommend?
Yeah.
Okay.
Yeah.
So there are two devices that our gear experts will typically recommend to folks. There are a few reasons for that. There may be others that kind of fall into all these tick boxes, but we haven't really found them. So the reasons that we always recommend these two are that first, the devices are isotropic, which means that they are constantly monitoring in all directions. So think 360 degrees, every single direction around you, so that no matter what's happening, it is measuring if you're being potentially impacted by RF, which means that these are the devices that can truly be said to be body worn. So the most effective PPE in this instance is something that you throw on whenever you're working, and it will alert you if you have a problem. There are other devices out there that are not isotropic. You have to walk to the broadcast position, turn it around a bunch of different directions, try to align it with however it's calibrated, and then maybe it tells you that there's a problem.
Right. So body worn, just because they can see the picture, they can't see what you're doing.
Oh.
So it's actually, they've got straps and a tether where you just attach it to your harness and turn it on, and they're compact, they stay out of the way. You can just go to work and not have to worry about taking it off, holding it away from your body, holding it in front of the antenna, that sort of thing.
Exactly. So body worn, isotropic, which is a big part of being body worn. The next thing that we would say is that you want to make sure that you pick something with a frequency range that gets to at least 47 gigahertz. And the reason we say that now is that the upcoming spectrum auction from the FCC, which is going to be concluded over the next several months, is going to unlock 47 gigahertz as a new frequency which can be used by wireless carriers. So there are a number of devices out there that used to kind of stay within that 6 gigahertz range. Now there have been some that'll push up to 40 gigahertz. If you purchase a device which caps at either 6 gigahertz or 40 gigahertz, and you plan on working around any of these potential hazards that we talked about before, it is a short-sighted purchase because within a matter of months, you could potentially have a device which is not going to pick up the signal which is being put out by the next generation of antennas that people put out. So up to 47 gigahertz, huge. The two devices that we put on the screen before go up to 60.
60, yeah.
I think, Connor, I think we have a chart that shows the different frequency ranges as well. So, sorry, it's a little far from me on this, but you can kind of see everything that is generally in blue is, and to the left where it says non-ionizing radiation, those are the frequency ranges where wireless generations could be deployed, right? So you can see part of the 4G, 5G, et cetera, is being put in those lower bands, but the higher bands have been used for a little bit, and that goes up to roughly 40 now. I think 39 is the highest, which is actively deployed right now. But because of the spectrum auction, obviously you can see that up to 47 is already there for 5G. And then I would not be shocked if we see something that pushes past 50 in the next several months as well.
Yeah, and on that chart we put those slash lines to show that those two monitors that we just talked about do go up to the full 60 gigahertz.
Right.
And then I kind of nerd out about this stuff, but you can see the 2G or was that CDMA went all the way down to 700 megahertz, and the frequency has just expanded over the last decade.
So I know that all this stuff feels really technical and we're talking about frequency ranges and things like that, but keep it simple, right? If we're talking about deploying an RF safety program for your workforce, and the reason that you want to do that is that they're working around wireless infrastructure, getting something past 47 gigahertz today is the key. So don't worry about all the math that gets there. If you buy a device which is set to work for wireless and it goes to 60 gigahertz, you're in good shape.
Yeah. One thing I do want to throw out about those monitors too is they can tell you how long you've been working in those ranges too. And that's a big part with the permissible exposure is you can work at 200% exposure as long as it's a certain amount of time and you take the time off outside of that zone too. I'm
glad you said that. The last kind of element that we would say when you're selecting a device, make sure you pick something that has what's referred to as a shaped response, which means that it's monitoring all frequencies and power levels, and it will give you a readout in terms of a percentage versus that permissible exposure level.
Yeah, it's not just good or bad.
Yeah, it's not, megawatts per centimeter cubed.
Yeah.
I don't expect anyone in any of these industries to know that stuff. I wouldn't be able to look at it and quickly at a glance say, oh, that gets me to 60%. It gives you that readout in a simple way so that a technician that doesn't have a bunch of experience working as an RF engineer can know at a glance, am I a risk or am I not?
Right. Okay, awesome. I think that's everything that I had. Did you have anything else you wanted to touch on?
I guess just a couple things. First, it's been a weird year, so I wanted to say thank you to our clients, suppliers, coworkers. Thank you for making 2020 as good as it has been. It could have been worse, but we've been blessed to have a number of solid partners internally and externally. Happy holidays to everybody. And then when it comes to this RF stuff, we don't need to have tinfoil hats. We just need to do the right thing.
Yep.
So got to thread that needle. Yep. Take it seriously enough that you're compliant. Don't freak out. It's not that hard.
Yep. Awesome. Well, thanks everyone for joining us. If you need more information on RF safety, you can check out our knowledge base, talk to one of our gear experts. They can get you to the right people if they don't know the answers. But it's a really important topic for not just telecom, but all industries these days. So thanks again for viewing, and we'll chat again soon.
Happy holidays.